Earth, the one-of-a-kind planet we call home. One of the things that makes Earth so unique is its habitability for a variety of life forms, particularly its suitable climate and atmosphere. There's a few factors at play here regulating the climate: plate tectonics, ocean currents, the atmospheric gases present, and others. In this video, we'll be focusing on only the atmospheric gases and the role they play in global climate regulation. So how do we find the average temperature of Earth? Well, one way would be to take the expected temperature based on the distance from Earth to the Sun, and measure the incoming sunlight absorbed by the surface. But this calculation would give us a temperature of around -16 degrees Celsius, way cooler than the actual temperature. In fact, the average global temperature of Earth is 15 degrees Celsius. So why is this? What's happening on the surface making our planet warmer? To address this question, we have to understand the greenhouse effect. And before you ask, no, this doesn't have anything to do with greenhouses. The greenhouse effect is the fundamental process that keeps Earth warmer than the expected global temperature. So let me explain how that works. It starts with light from the sun hitting the Earth. This is mostly visible light that passes through the gases in the atmosphere. Some of this light gets absorbed by Earth's surface, while the rest is reflected back into space. However, the ground does not return this light in the same way it receives it. Instead, it returns it in the form of infrared light. Some of this infrared light becomes trapped by the gases in our atmosphere, because these gases easily absorb it. These gases include carbon dioxide, methane, and even water vapor. These gases absorb the inferred photons, then release the energy by emitting a new inferred photon in a random direction. The cycle continues as other gases absorb this new photon and do the same thing. This slows the escape of the inferred radiation from the atmosphere and effectively acts as a blanket to the Earth's surface, keeping it warmer than it otherwise would be. And this isn't necessarily a bad thing. These gases have been present in our atmosphere for a long time, and in moderation serves a useful purpose. But with the industrial developments by humans, the levels of these gases have increased dramatically. Over the last century, humans have changed the atmosphere's composition by releasing large amounts of these gases, especially carbon dioxide. The more gas, the more absorption of the inferred radiation, thus leading to an increase in temperature. Specifically, a rise of 2 degrees Fahrenheit in just the 20th century. This graph of global temperature illustrates this trend. The Intergovernmental Panel on Climate Change, or the IPCC, forecasts a temperature rise of 2.5 to 10 degrees Fahrenheit over the next century. Although this may not sound like much, small changes in temperature have huge environmental consequences. These images show some of the sources of these greenhouse gases, and as you can see, most of it stems from transportation, industry, and electricity. This doesn't only affect temperature, though. The increase of trapped energy leads to our oceans absorbing more heat too, contributing to rising sea levels and a changing climate pattern. Carbon dioxide can be absorbed by the oceans too, leading to a decrease in the pH, a problem known as ocean acidification, carrying dire consequences for marine life. And the Earth? The outlook doesn't look great here either. Aside from the obvious loss of sea ice due to increasing temperature, climate scientists predict more frequent storms, droughts, and wildfires due to more intense and frequent heat waves. To combat the issue, many governmental agencies are proposing ways to cut back on emissions and prevent the future increase in temperature. Global climate change is even one of the most talked about situations, and helping fix the issue demands the participation of everyone. Thank you for watching this video. I hope you understand more about the ways the atmospheric composition of Earth plays a vital role in climate regulation and why this is so important for life on Earth.